We do still hear some background chatter, but I will try to talk over that. So hi, I'm Andy Grigorowicz. I'm a software engineer at the MITRE Corporation, and I'm leading an effort at ONC, reporting to Debbie Bucci, looking at record matching tools and libraries. And also Keith Miller, who Carmen mentioned before, is one of my colleagues here, and he will be assisting me here with this presentation. So next slide, please. So through a previous effort, MITRE created a solution that folks on the phone may be familiar with called Pop Health, which is, if you're not familiar with it, it is an open source electronic clinical quality measure calculation platform. If you're not familiar with clinical quality measure calculations, they are, at a very, very brief and high level, a best practice that you are trying to assess the care that a provider is giving to a particular patient. A common example of that would be checking to see if people are receiving their flu vaccination. And so you can run a report against the electronic health record system to see how many of your patients that have been into your practice have received their flu shot or not, and then you can be graded on those results. Now, ECQM calculations can be handy in trying to assess the care that your patients are being provided. However, as with any tool operating on data, the calculations are only as good as the data that they're given. So with any sort of computer algorithm, garbage in, garbage out. So providing data to an ECQM engine can be a challenge. If you are a provider or some organization attempting to aggregate this data, you may have patient data coming in via different streams. So you may have claims data coming in, you may have clinical data coming in, you may have data coming in from multiple clinical streams. So you may have patients at a primary care provider versus care that they receive at a specialist. And that often leads to the second bullet there, the notion of duplicate records that may exist for single individuals. So you could have a record for a patient being kept at a specialist that they see versus their primary care provider, and you want to be able to recognize that those are duplicate records, and you want to be able to aggregate the information across those. So given that, ONC approached MITRE and asked us, is there any way for us to enhance Pop Health to potentially address these different issues of data coming in via different streams and duplicate records and so on and so forth? So next slide, please. So ONC had a couple of things that they would like us to be able to do. They wanted us to be able to execute different patient matching algorithms against the patient data set. So this data set that we were going to calculate electronic clinical quality measures on top of. They wanted to be able to do things like compare algorithm performance. So given that we have a known set of matches, could we have a bake-off, so to speak, between different algorithms against the same data set? Also the ability to examine data set quality. So this would be a scenario where, let's say you have a data set, you have a patient database or a master patient index, something along those lines, and you run a fixed patient matching algorithm against it. So you would run your algorithm against a database of, say, 1,000 patients, and it identifies 50 duplicates. And then you, an organization, may implement some sort of data cleansing process, may implement a better patient registration process, and this algorithm continuously monitors the data set over time to see that the number of duplicates in that data set starts to have a downward trend, or perhaps you're monitoring it for quality to see, oh, we implemented a new registration process, it's creating more duplicates. So those are the two types of features that ONC wanted out of a patient matching test harness, if you will. They also wanted the ability to ingest claims data. So Pop Health, the previous platform, had the ability to ingest different standards-based formats. One of those was not claims, but we wanted to follow up on that. And then lastly, Pop Health sort of assumed that it was working behind a firewall. Anyone could kind of post data to it, and ONC had a desire to see some of those methods be secured through standards-based authorization and authentication protocols, which was something that we dug into. And then later on, as we were working through the project, there were two additional requests. One was, is there a way for us to potentially merge or unify duplicate records? And then also the ability to go in and examine individual record quality or completeness, and I'll speak to those a little bit later. So next slide, please. So we had this existing piece of software called POP Health that did electronic clinical quality measure calculation. And ONC gave us our list of requirements, and as we sat back and we looked at it, we really had two separate, two options at our disposal, in my opinion. On the left-hand side, we had this notion of it enhancing the existing code base. The POP Health open source project is battle-tested. It's been deployed in a number of production settings, so it has a certain stability or robustness to it. It also it really speaks the language of clinical quality measures, so there is a good harmony between clinical quality measure data formats and the measure formats themselves. So those were some things that were definitely in the column of supporting an existing code base. However, we also wanted to be forward-looking, and we evaluated moving a lot of our data access and storage and services to FHIR, which I'm assuming everyone is familiar with FHIR, but if you're not, it is a modern standard from HL7 for supporting the exchange and representation of health information. It is very much focused on simplicity compared to some of the other data standards. This is much more forward-looking as we see it gaining a lot of traction. And in a lot of places that POP Health was operating, and it needed to exchange information with other pieces of software or other services, we were using our own they were open, but they were MITRE-specific or POP Health-specific data interfaces. And this would allow us to build interfaces that are standards-based. So we decided jointly with ONC that we were going to go forward and sort of build a trailblazing approach and architect our solutions around FHIR. So next slide, please. So what we have ultimately ended up with is that we have created what we consider an open platform. And I will dig into each of the bits of this platform as we go along here, but from a high-level overview, this one of the reasons why I call this an open platform is that it is based on open source software, and it abides by open standards, freely available standards. So on the far left-hand side, we have our FHIR server, which is responsible for managing the patient data in our system. And then it also has a standards-based interface where different pieces of software can go and query it to get information about patients. That FHIR server is protected by two open authentication and authorization protocols, OAuth and OpenID Connect, additionally profiled by Harn, and I'll talk about that. And then you'll see there's a constellation of services that we have that can access this FHIR server through those open authentication and authorization protocols. We have electronic clinical quality measurement, patient matching, patient merging, record completeness, and a claims importer. And we'll dig into each of those. So next slide, please. So first, I'll talk about our FHIR server, which is really the bedrock of this open platform. Next slide, please. We have an open source FHIR server. You can see the URL there. It is under an Apache 2.0 license. So that is freely available for anyone to download and use in whatever system they would like. It has support for FHIR's version DSTU2 as well as STU3, so the two most recent revisions of the FHIR standard. And just to give you a flavor of the basic capabilities of this piece of software, you can ask it for patients and it will give you their demographic information. It can store their encounters, their conditions, medication orders, labs, those sorts of things. Those are all encompassed by the FHIR standard. This gives you an open and simple way of searching on that information, updating it, retrieving it, all through this HL7 approved standard. So this is the bedrock upon which we are building our infrastructure. Next slide, please. Moving a layer out from that, we have our authentication and authorization layer. which I'll speak to on the next slide, please. So our FHIR server can run in 3 separate modes for authentication and authorization. The first is unauthenticated. So the FHIR server is running in an open mode where you can make any sort of request to it to do any sort of operation, and it will just do it without you needing to log in or provide any sort of credentials. Obviously, that is for development purposes and not meant for any sort of production use, but you can use it for testing and whatnot. The second mode is that we have the ability to operate in what I am calling a plain OpenID Connect and OAuth 2.0 mode. Our FHIR server will act as an OpenID Connect relying party for authentication. What that means is that if you have some sort of identity provider that speaks OpenID Connect, Google is an organization that provides an OpenID Connect identity provider, but many identity management systems that you would bring in-house into an IT ecosystem for OpenID Connect. You can point the FHIR server to this, and it will confer authentication. And then, so you can have users log in at your identity management system, and then they will be redirected with their credentials to our system. It also acts as an OAuth 2.0 resource server. What that means is, as a user, you can delegate authorization for third-party software clients to be able to access our server. That would be things like mobile applications or different servers or services that would be performing analysis on the data that is in our resource server. And one other point that I'll mention on that is that the software supports the smart/heart scopes. And those are just ways of granting permission to particular parts of a patient's record. Lastly, what I'll say on this slide is that it not only supports the plain OpenID Connect and OAuth 2.0, or unprofiled, maybe a more accurate term for it, it also supports HART profiling of these 2 standards. HART is a work group. Justin, who is speaking later, has probably forgotten more about HART than I know about it. However, HART is a work group that produces a set of standards for or profiles for existing open authentication and authorization standards. Using those, you can achieve higher levels of assurance in the authentication and authorization through different cryptographic technologies. So you are able to do things like sign requests, and we support that additional level of security within this platform. Next slide, please. So in this open platform, we have the bedrock, which is our FHIR server, which we can secure, and then through that secure system, we can provide a number of different services to achieve the requirements that ONC had for working with this data. So the first of these is electronic clinical quality measure calculation. Next slide, please. What we were able to do with this is we were able to take the logic that we had from meaningful use stage 2 ECQMs. That's the same logic that was built inside of Pop Health and used by the Cypress and Bonnie projects. We introduced a different layer underneath that logic. So instead of querying data that we get out of one standard called QRDA Category 1, which is typically used in meaningful use systems, we were able to build a translation layer, if you will, so that now that those queries will hit against our FHIR server as opposed to a QRDA Category 1 document. So we now have this set of electronic clinical quality measure calculation services that can run against a FHIR server. They support all of the meaningful use stage 2 measures. And again, this is open source software available under an Apache 2 license. It is FHIR STU3 compliant. You can find our RESTful API available at the GitHub URL there, where you can stand that up and run it against our FHIR server. And we've also provided a web-based user interface that you can see below. I included a small screenshot of that, but that allows you to select clinical quality measures, click a button that will calculate the clinical quality measure against your population. You can see in a very small image there, it's calculated against a set of 206 patients. And the little circle there shows you the numerator and denominator population, so the people who met the criteria for the measure and the people who did not meet the criteria for the measure. Next slide, please. Another aspect of our open platform is we built a claims importer. So next slide, please. One of the, as I mentioned at the beginning of the presentation, we wanted to be able to incorporate claims data so that we can get more information about a patient. FHIR provides places in the standard for storing claims information. So we at MITRE created software that will translate ASC X12 837 professional transactions into FHIR resources. Just to sort of translate that to those who aren't familiar with the claims world or the X12 world, 837P transactions are the type of messages that are typically sent by an individual provider when they're billing for outpatient encounters. So if you go and see your primary care physician for a typical 15-minute encounter, that will typically generate an ASC X12 837 professional message. And we built software that will translate that into a FHIR resource, so now you could take that billing stream and integrate it into the other data that you would have available to you in that FHIR server. The software was delivered to ONC, and we are currently exploring ways of making that software publicly available. So unfortunately, we could not release that software directly as open source, just to some of the intellectual property restrictions around the ASC X12 837 specification. But ONC is currently working with ASC X12 to see if there is any arrangement that we can make to potentially host this software and have a waiver in some way, shape, or form for this particular software package. So it is something that we have worked on, and I'm sure if there are questions about this software or making it available, I'm happy to respond to those, and I'm sure Debbie would be happy to respond to those as well. Next slide, please. Another service that is provided within this open platform, and one of the reasons why we're speaking here today, is patient matching. So next slide, please. So why does patient matching matter for electronic clinical quality measures? Well, this gives you a really simple example. Imagine that you wanted to find all encounters for William Q. Smith. And we're trying to pull data from a bunch of different places. So you can see there's a bunch of different providers and lab results coming in from different laboratories. And if I wanted to pull in data from the record of provider 1, which is William Q. Smith, versus provider 3, which has him as W. Smith, I would miss encounters that are coming from provider 2 through lab result 5. Now, if you go to the next slide, please. If I have good patient matching software in place, it will understand that William Q. Smith is the same as Will Smith, is the same as W. Smith, as William Quincy Smith, as Bill Smith. And therefore, when I go in to find all the encounters for this particular patient, now I can pull back all of that information. And that's often critical for calculating something like an electronic clinical quality measure, when you may want to be checking the number of encounters that a patient has had with a particular provider to make sure that they're getting a standard, they're meeting the standard of care. And actually, it's more than a particular provider with a lot of electronic clinical quality measures. We want to make sure that the patient in general is getting the care. We don't necessarily care who the provider is. We just want to make sure that the patient is getting the appropriate treatment. And so being able to do this querying across the different data sets is important. Next slide, please. So what did we have as an objective based on how ONC was directing us? We wanted to determine a standards-based interface into patient matching systems. So what we found is that there are a lot of great commercial identity matching systems and patient matching systems. However, they typically require some sort of custom integration into your enterprise. There's no standard that we could find where you would be able to easily swap a patient matching system in and out in an enterprise without a lot of pain. We wanted to create a tool that could assess multiple patient matching algorithms. I kind of spoke to that a little bit in my introduction. So we wanted our tool to be able to assess how different matching systems would work against a given data set. And again, we also wanted that tool to be able to assess a process over time, again, being able to look at a data set, see if the number of duplicates in that data set goes up or down. Next slide, please. So what we did is we created a patient matching test harness that works with our FHIR server. But what we also did is, you'll notice here that I've introduced another box, the record matching system. What we did is we built a specification that tells record matching systems how to interact with FHIR to find the patient data that they need, to create patient matching, record matching system jobs, as well as report systems back in. So we built a patient matching harness that talks through our FHIR server, so it uses FHIR to communicate, and then it provides a way for record matching systems to use that FHIR-based interface so that they can do their matching jobs. And that specification is at the URL that you can see at the bottom of the slide. Next slide, please. So this specification, in this specification, MITRE uses a FHIR bundle, which is a structure within FHIR, to describe a patient matching job. What that really means is that we'll put a query in there and we'll be able to say, search for all patients within the state of Massachusetts that are male. That is something that we can put into a FHIR bundle and put in as a job for a patient matching system. Patient matching systems can then look for these FHIR bundles as the jobs they're supposed to execute, and when they find them, they can then query the system. When they query the system, they'll be able to get all the patients, so they can execute a query in FHIR that says, give me all the male patients in the state of Massachusetts. The patient matching system will do whatever special sauce it has in its own matching system to look at those records. It'll look at their names, date of births, different identifiers for the patients, so on and so forth, and try to determine a set of matches in that given data set. When it creates that set of matches, it then puts those into another FHIR bundle, which uploads them to the FHIR server, where our test harness can then take advantage of them. We can present that as information to the user so that they can then see how a particular patient matching system performed against the data set. Next slide, please. So we realize that not every, there aren't essentially any patient matching systems out there right now that speak FHIR natively. So we imagined a number of different scenarios that you would have with a record matching system that you would need an adapter to be able to work with our given framework. So there's a number of different scenarios that we've sketched out here. You can imagine an adapter. You have a record matching system that takes comma-separated files or CSV files. We could build an adapter that would be able to take CSV files and send them off to the matching system, receive CSV files, upload those to our FHIR server. Some record matching systems maintain their own database, and you would need to build an adapter for that. Obviously, you could have the record matching system that speaks the protocol natively, or you could have a system that has a different type of messaging interface. So you could imagine it doesn't speak FHIR, but it speaks its own XML RESTful protocol or SOAP type protocol. So there may be some sort of adapter that is necessary there. Next slide, please. So in recognizing that, what we did is we created an open source framework that allows you to adapt matching systems to FHIR. That is, again, available as open source. You can find that at the URL that we have provided. We've also created a fully worked example. So there is an open source matching system called Frill. So we have a fully worked example, if you will, where we have taken this open source Frill matching system, built an adapter to it so that it is able to look for jobs as FHIR bundles, do the matching against the FHIR patient resources, and upload results into our FHIR server where our test harness can inspect them. Next slide, please. What we have is we were able to create a patient matching test harness, and this is a service that allows you to create a set of matching jobs. So you can go in there and specify your data sets. You could say, I want to have a data set in my FHIR server that might be all the patients in the FHIR server, or you could say all the male patients in your FHIR server, all the female patients in your FHIR server, all the patients born after such and such a date. However you can structure it as a FHIR query, you can create a data set. You can also upload answer keys. So if you have a data set that you have a good ground truth set for, where you know the matches within the data set, we support uploading the answer keys so that when someone reports the matches for a given data set, we can then score these systems against that particular answer key. Now, those answer keys are often hard to create, which my colleague Keith will speak to in just a moment. Again, this is all available as open source software. The ability to create these matching jobs and create data sets is all available via a RESTful API. And we also provide a web-based user interface that you can find the source code for at the URL given here. And I've provided a screenshot of what this looks like when it's running below, and you can see we are comparing a number of different matching systems, how they have performed on patients in Massachusetts. I apologize, the type is kind of small there. And we have these little radar diagrams here where we are showing different metrics on how these systems are performing, so we can calculate the F-score, the precision, the recall, and then at a glance you can see how these different systems are performing against those given metrics. Next slide, please. So I did mention that one of the things that can be difficult is building a good answer key and trying to find, and that feeds into sometimes it's difficult to evaluate patient matching systems. And to speak to that, I'm going to hand it over to my colleague Keith Miller.
Thanks, Andy. So as Andy was saying a minute ago, we have a test harness into which we could hook multiple patient matching algorithms if we wanted to see what the effect was or the effectiveness of each of those algorithms is. The test harness itself doesn't necessarily include the ground truth data or the ground truth data set, or in other words, the answer key that's necessary for evaluating the systems. It provides all the plumbing and infrastructure necessary to hook the systems to a scoring server and a place that you could actually calculate these metrics. So just like Andy was referring to a minute ago with the ECQMs, garbage in, garbage out, same with evaluation with your test data set, garbage in, garbage out. So you want to take care to produce a test data set with known ground truth, known duplicates, that you actually have pretty high confidence in the quality of. And so that's what I'm going to talk about for the next few slides is desiderata and challenges in building that ground truth data that would be supported through this test harness interface. So a couple of these, on that same slide, a couple of these characteristics look like they should be sort of motherhood and apple pie, and everybody agrees with them right off the bat. But let me just take a second to go through them, because it's not always a given that every evaluation or every test data set meets all of these criteria. And so if we're going to be comparing patient matching algorithms and their ability to accurately match patients, we want that evaluation to be objective and replicable. And what do I mean by that? I mean that I should be able to run the evaluation, Andy should be able to run it, ONC should be able to take the data set and the protocol and run the evaluation and get the same results. Now, that's not possible unless we have a static and known test data set and environment in which we can actually control all of the underlying data and control the data both being searched on and the data that is being searched for, as well as the system configurations. And so we need that type of arrangement in order to have an objective and replicable evaluation where we can compare apples to apples. Additionally, ideally, the evaluation should be in some way diagnostic. And again, if all we're able to do is run a system in its operational mode and eyeball the results and say, oh, it looks like that system's producing a lot of false positives, that's only showing part of the story. What I don't know from an evaluation, quote-unquote evaluation or assessment like that, where I'm saying, okay, I'm just gonna tighten up the system until it stops producing so many false positives, is I don't know anything about the false negatives or the potential match records or patient matches that the system is missing, because there's always a balance between trying to find all of the relevant matches and trying to find only the relevant matches. And so with a known high-quality test data set, it's possible to diagnose both cases, the cases in which the system is producing false positives and the cases in which it's producing false negatives when you start tightening it up to eliminate those false positives. Ideally, the evaluation would be cost efficient. Everybody likes that. It does cost a little bit of money up front to create the data set, but once you've created it, you can reuse it over and over and over again, as long as you keep the answer key close hold and you don't start letting either your system developers or external system developers start training on that answer key and training to that answer key. at which point then that evaluation set is much less useful, and you have to build a new one the next time you want to do an objective and fair evaluation. Again, obviously the evaluation results should be understandable for the people that want to consume them, and so I might produce different set of evaluation results for developers who are down in the weeds versus managers and workflow managers who are really trying to optimize the productivity of the people doing the duplicate review, reviewing the duplicate reports, and actually performing the record merges. I might have different outcomes and different focuses for those two types of evaluations. And obviously, the evaluation should be well documented. Next slide, please. So, one thing that we try to do in order to meet all of these criteria is we normally follow this 7-step recipe for evaluation. This recipe was originally developed by a joint NSF and EU, European Union working group under a project called IL, the International Standards for Language Engineering, and was originally, if you see that in the blue box down there, developed for evaluation of machine translation. But the authors note that it should be usable for evaluation, system evaluation in general, and generally it's just a good systems engineering approach to evaluation. We've used it a lot for information retrieval type evaluations, of which patient matching is a very specific case. And what we noticed when we started to apply this regularly was that it was quite tempting, and quite often people wanted to jump straight to step 5. They said, we're doing an evaluation, okay, great, what metrics are we going to use? We're going to use some kind of accuracy metric. Okay, let's start there. Well, it turns out that if you do take the discipline to back up and start with step 1 and define the purpose of the evaluation, why are we doing this evaluation, that can actually have an impact on all of the other following steps, including and especially steps 5 and 6. And so thinking about why we're doing the evaluation, are we doing the evaluation because we want to optimize patient query when a patient walks into a doctor's office and they're pulling up a medical record, and can I pull up the correct medical record, single medical record for that patient? That's one use case. It might be a different use case if I'm saying, well, I want to optimize the creation of my duplicate review queue when I'm analyzing my entire data set for potential duplicates, or merging 2 data sets and deciding if there are duplicate records between the two. Those are 2 very different use cases, 2 very different operational constraints in terms of how much time somebody has to look at records and decide whether they're duplicates, and differences in workload in terms of how many records can I actually look at to determine whether 2 records match. You know, if the patient is standing in front of me, can I actually look at maybe 2 or 3 records that aren't that patient, as long as I can ask that patient, hey, are you actually William Q. Smith, as opposed to William H. Smith, because you have that interactive verification. So that gets to step 2, actually, where you're elaborating the task model. How is the system used in the workflow that you're actually thinking about optimizing or evaluating? From that, you can decide on what are the important system characteristics and then requirements that a system must satisfy in order to be useful in that use context. And then we can think about, okay, what are the metrics that I would use to evaluate whether a system is doing well on those system requirements. And then develop your technique to measure and carry out and interpret the evaluation. Now, the technique often will involve something like building this ground truth data set, this set of known matches, known duplicates, and that's what I'm going to talk about in some of the next slides. Next. So when I'm actually trying to build a data set for a ground truth data set of known duplicates, as I said, the first step is to determine why the evaluation is being done. And one of the reasons for that is there's different truth for different applications. As I mentioned, the case where the patient is standing in front of the physician versus a sort of, a lab where a whole bunch of people are looking at a big duplicate review queue, 2 very different applications. And I might have a higher or lower tolerance for false positives and false negatives in those 2 different use cases. And so the answer key for the testing of the systems might be very different for those 2 use cases. question that you want to ask is what's the cost of missing a match? And so the missing a match, again, that's the false negative. So what's the cost in the healthcare use case? Well, it could be a patient safety event due to missed medications, or you don't see allergies that a patient has that's on one record that's not on the other record. Could even lead to serious complications or death. And of course, in the context of the talk today, we're talking about ECQMs, and if you're mismerging two records where one has a diagnosis and another has a treatment by a specialist, well, the ECQMs can be incorrectly calculated. Conversely, the cost of wrongly identifying a match, I accidentally matching two records that shouldn't be matched, and if they actually get merged, known as an overlay, what's the potential cost there? Well, again, patient safety events, you can end up giving the wrong medication or the wrong treatment to a patient. Obviously, organizations, hospitals are very, very concerned about this because it can lead to lots of liability on part of the organization. Also, a violation of HIPAA laws if you're releasing the wrong medical information to the wrong patient because two patient records were merged. Again, death is always a possibility. And then secondarily, again, in the context of this talk, if you are merging diagnoses and treatments from various patients, again, your ECQMs can be incorrectly calculated. So all of this taken into account, when you're building the ground truth data set, the criteria for what you're going to consider a match in your test set has to be very, very carefully established and well understood and well documented. And Carmen didn't belabor this point during her presentation, but one thing that's been going on in the OCEAN project is to work on the adjudication guidelines, the guidelines for the people that are going to be reviewing these true positives and false positives, so that they know, even though it's their job, some of their jobs every day to actually do the merger, the merger decisions of the records, it's important that they realize that that's not the question that we're asking them. We're not asking them, are these the same people? We're asking them, are these sufficiently similar to be part of a duplicate review queue? Because that's what we're trying to do, is optimize the duplicate review queue. So the question that you're asking the annotators has to be really carefully phrased. Next, please. So other issues are how much time or expertise is available to judge or discount false positives. Again, those two different use cases. Again, garbage in, garbage out. Evaluation results are only as good as the truth on which they're based, and if you're going to use this test set over and over again, it's very important to be very careful about the construction of it. And absolute recall, or the false negative rate, the opposite of the false negative rate, is impossible to measure without a completely known test set. Next, please. So some things that we think about are what are the identity elements that are available to us. And obviously, a lot of times you start with name only. Then you might have date of birth. In the medical record context, you might have a medical record number. You might have a social security number, et cetera. You often, in the medical context, don't have biometrics, but you might have other elements that could lead to a stronger confirmation of a match or non-match decision. And then how do you evaluate each of the identity attributes for a match and no match decision? So if you hit the next, you'll see that if we have one record with B. Smith, that should definitely match a Bill Smith, probably even if the last name is typoed or spelled slightly differently, most likely if all the other attributes are the same. Next, please. Bill Smith should match William Smith. Next, please. William Smith should match W. Smith. And next. But the question is, how far do we go, and do we make this? We can't make this a completely transitive relation, because obviously we don't want all of the B. Smiths to match all of the W. Smiths. If we open up our gates that wide on our system, then we're in for a ton of false positives. And likewise with dates of birth, if you hit the space bar a couple of times, you'll see that, next please, yeah, great, stop there. So the date of birth, 10/12/1972 and October 11th, 72, not as obvious at first glance, but it's only a day off. You have to do a little bit of mental gymnastics for that. For December 10th, 1972, that's a day-month swap, which is more obvious when you look at the other format, 12/10/72. So if we're dealing with American hospitals and European hospitals exchanging data, maybe day-month swap is a very common thing, so maybe we want to weight that very highly in terms of a potential match. If it's not really a thing that's going to happen because of our data entry methods, maybe we want to say there's no way that's ever going to happen, so I don't consider that a good match in my system, in my context. And the final one was a year of birth in 1927. Calendar distance, that's way off, and no calendar distance algorithm would ever consider that a match, but actually, typographically, it's only a transposition of fat fingering, and so it could very well be a match. So we should take calendar distance and string edit distance into consideration when we're looking at dates. Next, please. And then how do you evaluate the combination of identity attributes for a match and a match decision? So if it's Bill Smith versus B Smith and the dates of birth are 10/12/72 and 12/10/72, is that a match or is that not a match? And that all depends on the interplay between all of these elements. Next, please. So Carmen, I'm not going to spend very much time at all on IMAC. Carmen already was nice enough to present that in the context of the OCEAN work, but IMAC is the adjudication collector, the identity matching adjudication collector. And it's just a lot nicer way to do it than giving your adjudicators a spreadsheet with columns and columns and columns of identities and asking them to perform the adjudication task in a spreadsheet or other type of environment like that. It's built on the mean stack. It's actually not quite mean. It's more men because it's mean without the angular in the front end. And on this project, we're actually working to open source this alongside all the other pop health software that Andy was talking about. Next, please. I'll show you a screenshot or two of IMAC. So on one screen of the adjudication collector, we constantly provide the adjudicators with potential record pairs that they need to decide are a match or not a match. Next. So this is a record pair, as the same one Carmen showed actually, where the only thing that's bolded is the thing that's at all different. Any difference at all would cause bolding between the two. Any difference at all between the two records will cause bolding, because if we start saying, oh, is it close enough? Is it only a day off in the date of birth? Well, then we're starting to actually write the identity matching algorithms that we're trying to actually create the ground truth to evaluate, and it's a very slippery slope. So we say exact or not exact is the only distinction we're going to display in the adjudication collector. And we also don't want to bias the adjudicators. Hit next, please. Mouse hover over can allow the adjudicator to mark something as either unknown or undecided, next, or negative, next, or positive. And once they've marked it, they just click next, and then they go to the next screen. Next, please. And also, because some people prefer keyboard shortcuts, there's a keyboard shortcut method of doing the adjudication rather than using mouse and mouse hover over. Next, please. There's an admin screen that lets us manage all of the IMAC users, as well as to carefully phrase that question or change the question that's being asked of the adjudicators if we decide that we need to be more succinct, and also control the layout of the identity matching information that's being presented to the adjudicators. Next, please. And finally, we're able to control all the query settings, including how many adjudicators we want to judge each match. We'll have, in the OCEAN project 2, we often have 2 or 3 adjudicators judge each match, and also set up a priority for the matches. We can do that here, as well as importing additional adjudications to be done. And the final screenshot, please, or the final set. Carmen alluded to adjudication conflict resolution. So if 2 adjudicators disagree, that adjudication goes into a state of conflict. If one adjudicator says it's a match and the other says it's not a match. So hit next, please, and we'll see that. So we can see here all the adjudications that were done, and I had 3 different logons, Keith, Keith 2, and Keith 3. And Keith 2 and Keith 1 thought that Bobby Smith matching Robert Smith was a maybe, and Keith 3 thought it was a good match, and so that's in conflict in that first line. And so if we go to the next screen, we'll see how that looks in adjudication conflict resolution. So in the conflict resolution, we can see what each adjudicator said, what the current decision is. If we do majority rule, here it's a maybe. And then the super adjudicator can make a decision. If you hit next, please. And they've decided, yes, that this is a true match, and so they can click click that, and next, please. And then we see in the conflict resolution screen that that's been judged by the super adjudicator admin as a true match. And if you hit next, we can also filter up on the right by showing only the conflicts, and we see now that there are no conflicts left to be resolved. And so now we've been through the whole process, and we have adjudications and or super adjudications for every item in the test set. And that's sort of the nutshell version of how we go about creating a ground truth test set. And I'm going to hand it back to Andy to wrap up.
Thanks, Keith. So we talked about we spent a lot of time talking about patient matching. The last two services that I'm going to focus on together here are patient merging and record completeness. So next slide, please. Out of all the services on our platform, these are the ones that are still undergoing significant development. We have what we're calling a FHIR Score Card. It's similar to the consolidated CDA scorecard that you have that is available on the ONC site environment. But what we're building is a service that will be able to assess the quality and completeness of a given patient record in FHIR. So an example of what that will be able to do is it will look at the allergies that are listed for a patient, and one, it will determine are there any allergies, and if not, is there an explicit declaration that a patient does not have any allergies? There are ways of doing that in FHIR. The same with conditions or medications. That allowing us to assess the quality of a particular record. And then we're also working on, you can see a user interface mock-up that we have for a service that will be able to do record merging that we're working on in March. That is due in March. It's well underway, and that's a notion where you could provide two different records that you've identified as a match, and then work them through this software to try to combine them or unify them into a single record, where the service will try to assist you, but then ask for human intervention if it can't figure out how to resolve it itself. But those are two services that we are currently working on, and with that, that's really a drive through the platform that we've put together, and I realize I think we've taken up all of our time, but I'll take any questions.
Fantastic presentation. Thank you very much.
Thank you.
I agree. Thank you very much, Andy. Was there any questions from anyone else out there on any of the patient matching presentations we've had?
So Andy, you'd mentioned that a lot of this is going to be available on GitHub. So if we just click on the link, then there's an opportunity to play around with that, or at least look at some of the information you've got there.
Absolutely, yes.
Okay, fantastic.
Just out of curiosity, can you tell us just a little bit more about the CCDA validation? I thought I heard you mention you were doing CCDA
Alberto,
validation.
could you speak up a little bit? You're very soft.
Oh, sorry about that. Could you tell us a little bit more about the CCDA validation work you did in terms of how thorough it is and how that compares to, say, the NIST schematron or the validator? I realize that validators online are just checking for content, but you're actually checking for the validity of the data or the validity of the document. Isn't that correct?
That is correct, although I was trying to go quickly and maybe I wasn't clear. We are not building a consolidated CDA scorecard. That already exists. I was referring to the one that is available at ONC already. We are working on something like that for FHIR. So the work that we are doing within this effort is to validate that a FHIR record conforms to a given set of rules that we've put together. And that validation happens at a number of levels. We're validating the structure to make sure that it's well, the documents are well formed.
Have you got to try going outside, because you haven't been outside all day.
Someone needs to go on mute.
Shall we try that? I really have to.
It's a good idea to go outside every once in a while. But it will validate It will validate the structure. It will validate that codes for a given resource match the codes that are expected. So, for instance, that observations are recorded with LOINC codes, although there are probably other allowable code sets. And then it will also check the presence or absence of certain pieces of information. So, again, allergies and intolerances being a common case where it will either look for a list of allergies, and if one is not present, it will look for an assertion that there are no known allergies for this given patient. But again,
I'm sorry. I give you a lot of credit with what you're doing, particularly since FHIR is such a versatile, such a versatile standard. Or non-standard. It's such a versatile standard that what you're trying to do is very, very hard. That's great. It needs to be done.
And again, the URL for that piece of software is in the presentation, so that one is a little bit further along, and if you have any suggestions or rules or questions, please don't hesitate to contact me. Please don't hesitate to reach out to the team. We are happy to take any suggestions.
Thank you, sir.
Or software. This is open source, and we welcome contributions.
Thank you, sir.
Okay, thank you, Andy. I'm going to turn it over to Justin now.
Hello, everybody. Like Andy, I want to remind everybody to mute and